Section 5.2 is the systems of equation in three variables. They're going to give us our three equations with three variables. And the idea that we're going to use is we're going to take it from three variables, eliminate one, go to two variables, eliminate one, go to one variable. Once we get to one variable, then we're going to back substitute. We're going to take our one variable, plug it in here, and we're going to solve and get our second variable. Then we're going to take our first and second variables and plug it into the first equations that we were given and solve for our third variable. Okay, so we look at our original problem, and to keep these organized, I'm going to call this one equation 1, I'm going to call this one equation 2, and I'm going to call this one equation 3 just as a reference, so when I'm speaking about it you'll know. Alright, we have to choose a common variable to eliminate, so I'm just going to choose y. Okay, I'm going to eliminate y in equation 1 and equation 2. Okay, that's the idea I'm using. So I'm going to write down equation 1 there, and now I'm also going to write down equation 2. Once I have both of my equations written down, I need these y's to eliminate. I need one to be negative, one to be positive. I need these coefficients to be the same. So when I see that, I recognize that this second one, that I need a 3 right there. So I multiply this whole equation by 3. I leave this first one alone, so I'm going to have this. In my second equation, I'm going to distribute this 3 out. So I have 3x plus 3y plus 3z equals 0. Now I'm going to add down, and I'm left with 5x, my y's eliminate, which was my goal, plus 4z equals 5. Now, I eliminated y from equations 1 and 2. Now I need to eliminate the same variable, eliminate y, but I'm going to use equations 2 and 3 this time. Okay, so the first time I used the first two equations, and my next time I'm going to use the second two equations, and I'm consistently eliminating the same variable. So I'm going to write down equation 2 now, and I'm going to copy down equation 3. Once I have my two equations written down, I need to figure out what's going to make these y's eliminate. I need one to be positive and one to be negative, and I need these both to have the same coefficient. So I need a 2 here, and I also need it to be negative. So that means I need to multiply this whole equation by a negative 2. So I'm going to do that. I'm going to distribute, and I get negative 2x minus 2y minus 2z equals 0. And I'm going to copy this equation down exactly like it is. Once I get it copied down, I'm going to add down, and I get 2x, my y's eliminate, which was our purpose, plus 2z equals 4. Now, I have two equations and two variables, so now I only have two variables here, and I have those same two variables here. Now I'm going to take my two variables right here, and I'm going to write them over here so that I can eliminate. I have 5x, let me start that over. I have 5x plus 4z equals 5. That's this equation. And now I'm going to write down this equation right underneath it. 2x plus 2z equals 4. Once I have that down, I'm going to choose to either eliminate the x or the z. Now I need to go down to one variable. Let's just do the z. I need one to be positive and one to be negative, and I need these to both be the same. So to make this the same as that, I multiply it by a 2, and I need one to be positive and one to be negative. So now I'm going to just copy down my first one. I'm going to copy this one exactly as it is. Now this second one I'm going to distribute. Negative 4x minus 4z equals negative 8. That gives me x, these cancel, equals negative 3. Now we said once we got to one variable, we would back substitute. So I take my x is 3, I'm going to substitute it back into either one of these equations. So I'm just going to back substitute it into this next one. So I have 2, and instead of x, I'm going to put this negative 3 right there. So I get negative 3 plus 2z equals 4. And now I'm just solving for z. Add 6, and I get 2z equals 10, divide by 2, and we get z equals 5. Well, now I have an x, and now I have a z. I go back into any of these original equations and substitute those values in. Equation 2 looks the easiest, so I'm going to use equation 2. So I have x plus y plus z equals 0. And now I'm going to substitute negative 3 for my x, and I'm going to substitute 5 for my z and solve. So I get y plus 2 equals 0, subtract 2, y equals negative 2. Now I have my x, my y, and my z. I'm going to write them as in ordered triple. X comes first, then y, then z. This is the solution to 3 equations and 3 unknowns. An equation in 3 variables, I mean. Okay, I'm going to try to make our plan a little clearer because we took 3 variables and we eliminated, we took equation 1 and 2 and eliminated variable y. Then we took equation 2 and 3 and we eliminated y also. So we went from 3 variables here to 2, right here in red. Now I have an x and a z, I have 2 variables. X and a z, I have 2 variables. I took these 2 equations in red and I wrote them here, and I eliminated till I got 1 variable. Once I got 1 variable, I back substituted, got my other variable, and then once I had these 2 variables, I back substituted into one of the original problems, one of the original equations, and I found my 3. So that's what I mean by going from 3 variables to 2 variables to 1, back substituting until we get our solution.